Hi everyone, my name is Chukwuenyem. I'm a DevOps engineer at Venture Garden Group. You can find me on Twitter at Promise Preston. I'll be walking us through provisioning Kubernetes clusters using Terraform in Azure. This is going to be a practical session. You'd understand Azure Cloud, Azure Kubernetes Service, infrastructure as code, Terraform as an infrastructure tool, the tools employed in infrastructure provisioning, how Terraform is used for infrastructure provisioning, and the benefits for Terraform over other infrastructure provisioning methods. So at its core, Azure Cloud is simply a public cloud computing platform owned by Microsoft. It's more like other cloud providers like Amazon Web Services, like Google Cloud Computing, DigitalOcean, Heroku, and other ones. They provide infrastructure as a service, platform as a service, and software as a service. We'll be walking through Kubernetes as a service, which is a platform as a service. I'll be taking us through that today. So here's a tour of the Azure Cloud Services. You have media and CDN category, you have data, you have analytics and IoT, you have compute services, you have a lot of services here, and they're based on what you want to achieve and all. So what is Kubernetes? With the rise of containerized applications using Docker, Containerd, we have companies running hundreds of containers, tens of containers, thousands of containers, and all. They come content with visibility, with scalability, with managing these containers and all, and that give rise to Kubernetes. So Kubernetes is an orchestration tool for these containerized applications. It tries to control resource allocation, it tries to control traffic management, it tries to control scaling, and a lot of other benefits that come with Kubernetes. It helps you run these containers at scale on the virtual machines that are nodes. You can run multiple containers in these virtual machines, which are the nodes, and then you have the control plane that sends instructions on how the desired states for these containers would be. So up next, we'll try to explain some of the components of Kubernetes. We have the Kube API server, which exposes the Kubernetes API. We have etcd, which is used for consistent data backup, like your data store. And then you have the Kube scheduler, which watches for newly created pods. So pods are like the smallest units in Kubernetes. And then you have the Kube controller manager, which runs controller processes. You have the cloud control manager. You have node components as well, the kubelets, the kube proxy, and then you have the container runtime. That's where Docker and the Containerd also come in. So what is Kubernetes? Azure Kubernetes Service. So Azure Kubernetes Service is simply managed Kubernetes cluster hosted in the Azure cloud. What Azure does for you is they do all the management for you. They manage the Kubernetes API service. You only need to manage the nodes yourself. You only need to manage where your containers run. But for the control plane, it's managed by Azure. So all you do is to manage the nodes yourself, where your pods are going to be running. That's what you do. So AKS in itself is free. What you pay for are the agent nodes within your clusters. So you don't pay for the masters, you don't pay for the control plane. So there are a lot of tools for provisioning Azure Kubernetes service. have the Azure CLI. So this can be achieved by installing the Azure CLI tool and then running a set of commands, which I'm going to show us and I'll walk us through. You have the Azure portal, more like the web-based, like the GUI for Azure, where you go and then you click through some buttons, you select the kind of cluster and some other information about the kind of Kubernetes cluster you want to set up, and you set it up. You also have Azure PowerShell, more like Azure CLI, but this is primarily for Windows machines, targeted at Windows machines. So you have a set of commands as well, with which you can set up Azure Kubernetes services. And then you have infrastructure as code tools. That's where you have Terraform, Azure Resource Manager templates, and AWS Cloud Formation. All these are infrastructure as code tools, but in Azure Kubernetes services, you'll be looking at Azure Resource Manager, you'll be looking at Terraform, and a few other tools. You also have Ansible, which can also provision infrastructure, or it's majorly or primarily a tool for configuration management. But today we're going to be talking about Terraform, how we're going to use Terraform for to provision Azure Kubernetes service. So what is infrastructure as code? So it's a process of configuring and managing infrastructure through a descriptive method. You simply describe how you want your infrastructure to be, and then you send the request, and Terraform helps you keep your infrastructure at that state. So, what is Terraform? Terraform is an open source infrastructure as code tool for building, for changing, and for versioning infrastructure safely and efficiently. Think about it this way. Think about the time you set up your first VM. What did you do? If you set it up on Azure, all you did was you went up to your Azure portal, you checked for VMs, you clicked, you tried to select the kind of VM you want, and then you're able to create it. Think about the time you tried changing some configuration for your VM. You had to go to the Azure portal again, you had to change some things, and you really can't tell the difference between the states your VM was and then the current state it is. You can't tell that difference so well. What Terraform does for you is Terraform helps you describe how you want your infrastructure to be per time. It uses a language called HashiCorp configuration language, which is HCL. HCL uses an extension called .tf. What it does for you is it helps you describe the desired states, and then you run that script. What that script does is it sets up the configuration for the VM based on how you want it. And then everything is applied. And the good thing about this is you can version control this. So you can add this file to say Bitbucket or GitHub, and per time you can tell. So at on the 5th of May, we changed from this point to this point. You're able to tell per time what's changed on your Next, benefits of adopting Terraform for infrastructure provisioning. So it improves multi-cloud infrastructure deployments, it automates infrastructure management, infrastructure as code, like I've talked about, reduce development costs, reduces time to provision. So let's say you have your scripts already, you can provision 30 VMs in just a few minutes, unlike when you have to go to Azure portal to do all of that yourself. And the good thing about it is with Terraform, you can provision infrastructure for various cloud providers just with Terraform, unlike having to provision on AWS and you have to use AWS Cloud Formation or Azure Resource Manager templates when you have to provision infrastructure on Azure and all. But this time you're just using Terraform, and Terraform uses a concept called modules. With modules, you can be able to provision any kind of resource in any kind of cloud provider that you want. All you need to do is you check up the documentation on Terraform for that provider, and you're able to tell how you can provision infrastructure on them. So requirements that will be needed for provision Kubernetes using Terraform, we'll be using Azure CLI, you'll be using kubectl, we'll be using Terraform, we'll be using an Azure account, we'll be looking at the Terraform registry docs for Azure Resource Manager. We'll also be looking at the Azure CLI documentation as well. All right, so we'll be going through some practice session right now. So let's walk through this together. Okay, everyone, this is the practice session for provisioning Azure Kubernetes cluster using Terraform in Azure. I'll walk us through this. On my left is the Azure portal. On my right is my code editor. I have a folder called HashiCorp here and another folder inside it called HashiTalks. It's inside this directory that we are going to create the files that we'll use for provisioning Kubernetes in Azure. So first thing first, I'll need to confirm that I have Terraform installed. So the way I'll check that is by running Terraform version. And yeah, I have Terraform here. I'll also confirm that I have the Azure CLI set up. I'll also confirm that. So yeah, we have that. All right, so the next thing I'll need to do is AZ login. So what AZ login helps me do is to authenticate to Azure. I'll need my credentials to be able to do that. So I'll just type in AZ login. It would open up my browser here to confirm that I log in. I'll do that. And once I do that, I'll get a confirmation that I've been logged in, so I can close this. So it confirms that I'm logged in. You can see promise Preston at outlook.com. And then it tells me the active subscription I have here. It tells me all of that. So all that I'll do, I'll copy this out because I'll need it very soon. So I'll copy that out. I'll copy that out. Okay, next. The next thing I'll do is I would create a service principal. A service principal is the same thing like you have with creating a user, but the difference is you're creating a user with programmatic access. So you're creating a user that simply communicates with the Azure API, not an actual user that logs into the Azure portal, but you're creating a user that just has programmatic access. In other words, a user that's able to send instructions or commands to the Azure API. So how do we do that? We go to the Azure Active Directory. And then we go to app registrations. So we'll click on register, click on all applications, and click on register an application. So we're gonna call this HashiCorp. Okay, let's call it HashiTalks. 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 Single tenants, let's call this HTTPS. HashiTalks. And let's register. Okay, that's been successfully registered. Next, let's take note of the application client ID. So let's copy this out. We're going to need this later on. Also, let's copy out this directory obtain an ID. You copy that out. Next thing we're going to do, we need to add a certificate or secrets. You can do that from here, or you can also do that from here. So let's click on it. So this is the credential that will be used for authentication for this user that we just created. That's the service principal. We want to use a client secret and not a certificate for this. So click on new client secrets. So you can enter the description. This is for HashiTalks. Expiry, okay, and then we update it. So next, we'll copy out this value because it's very important. The secret ID is not really essential for us. So let's copy this value out. So password. So I've copied that out. The next thing we want to do is we want to give this user some kind of role. So how do we do that? We'll go to our subscriptions. We'll select the subscription. So if you find here, you'll realize subscription I'm using is Azure Subscription 1. So we'll go to Azure Subscription 1. Okay, so we'll go to Access Control IAM. All we're trying to do is we're trying to assign a role. We'll go to add role assignments. And then we'll select the role. We're trying to add a contributor role here. So we'll select contributor. And then the user is a user group or a service principal. So we'll type HashiTalks. Okay, it pops up. And here you go. So we save this. Okay. The next thing we'd want to do is we'll have to go back and then also get the subscription ID for this. So we'll copy out the subscription ID because we are going to need it for the authentication. Now we need to set up the authentication for Terraform. All right, so we have that all together. The next thing we'll do is we'll go to the docs for the Azure provider on Terraform. So you can go there, you can just go to registry.terraform.io and then you search for Azure. So you type Azure. Once you type Azure, it pops up and then you have this. So the first thing we want to look at is how do you authenticate to Azure? So you have a lot of ways to authenticate, but we're going to be authenticating using a service principal and a client's secrets, which is the fourth option we have here. So how do we use this? We have a lot of ways this can be used. So the first thing we'll do is let's create a Terraform file. So we can call this Azure Kubernetes service.tf. I told us the file is usually a .tf file. So .tf. And the next thing we want to do is we'd want to copy this out. So we'll copy this out. Like I said, a lot of what you need is already on the documentation. So we'll pull this up first. The next thing we'd want to do is we want to figure out how we're going to authenticate. So let's go back to this end. Let's open this and then let's check. Let's understand how they want us to authenticate. So we can authenticate through various means. Let's go through. So the same thing we did where we had to create the user here, the service principal, and then we had to come to subscriptions to give permissions. We can achieve the same thing using just this command exec and then create for every back with role contributor and then with scope, and then we provide the subscription ID here. I prefer to go the other route to allow us to understand that rather than just running this command. So they've provided us with all this, and then we can also log in this way as well. But we are using Terraform and we're running this in a script, so we need a way to add that to Terraform. So let's go back to the docs again. This is the provider, so authentication is done here. Would look for different arguments that allows us authenticate using the subscription ID. So there are a lot of arguments here. So the following arguments are supported. So you have features. So we can also add the client ID, we can add subscription ID, and then we can add tenant ID. So that's what we are going to do to authenticate. And here, when you're authenticating using the client's certificates, these are what you need. And over here, when you're authenticating using a service principal as a service principal, so when you're authenticating as a service principal using the client's secrets. And then over here, when authenticating as service principal using client secrets, this is what you need. You need these client secrets. So what we're going to do is we're going to get the subscription ID, which is this. So we come over here, subscription ID. We copied out these values before now. So let me pull this up here. Our subscription ID, this is our subscription ID. We'll replace it with this. The next thing we'll check, we also need our client ID here. So let me reduce this a bit so it's not filled everywhere. So we have our client ID. What's our client ID? So like I said, this is the client ID. So we'll pick it up. And then the next thing, our client secret, like we're told, let's get our client secrets. Our client secrets is the same as a password. Client secrets, we copy this. And then the next thing we'll need is the tenant ID, like we have here. Then we get tenant ID. So this is the tenant ID. Let's come here, tenant ID, and then we copy our tenant ID. Okay, so that's all we need for now on this. The next thing we'd want to do is we want to create the resource for Kubernetes. But Kubernetes needs a resource group. I want to create a resource. The next thing we want to do, we want to create a resource for Kubernetes. So we type Kubernetes here, and you'd have a resource documentation for it. We'll click on Azure and Kubernetes service, cluster rather. We'll click on, so here we have documentation for that. You need to create a resource group. You need to create the Kubernetes cluster and you need to provide other information for it. So we'll copy this. We don't need this for now, so let's leave that out. So copy this. Then come down here and we'll paste it. So I'll be closing this out for now. So I have no space. So a resource group is more like a container that houses different resources in Azure. Azure uses a concept of containers for categorizing different resources. All right, for this resource group, let's give it let's okay. So we have different blocks here. We have a block for the resource group. We have a block for the Kubernetes cluster, and then would be giving each block a reference name. So for this one, I usually give reference name using the first characters. So I'll name this AROG. And then we're going to name this, we'll be naming this resource group HashiCorp. What's it mean HashiCorp? Okay, let's go West Europe. And then for the Kubernetes cluster, let's also give it a reference name. Let's give it AKC. And then for this, we'll be naming it HashiTalks. Let's name it HashiTalks. Okay, so we have Azure resource group here, and this is going to be picking its location from this resource group. Like I told us, resource groups are containers. So would want to create this Kubernetes cluster inside this resource group. So the Kubernetes cluster would be inside a resource group. So resource groups are more like containers, virtual containers that houses different resources. So how do we tell it that it should create it under this resource group? All we need to do is the location we're going to specify. This is Azure resource group. It references this, and then the reference name will now be ARG. That tells it that I'm picking this location from this block. So pick this location dot arg dot location. And then the resource group name will do the same thing. We'll call it ARG as well. ARG as well. And then the name, it picks up this name. So it will create this cluster under this. The next thing we're going to do, let's give it a prefix. Let's give it a prefix of our choice. Let's give it HashiTalks -1. Okay, so that is it. The next thing we're going to do is we're going to look at the VM size. Are we okay with the default name? Are we okay with the node count? Are we okay with the VM size? The identity. For now, we're using system assigned identity. We're actually creating a basic Kubernetes cluster. Later on your own, you can add a lot of other things and all to it, but we're just trying to create basic infrastructure here. We're just trying to create basic Kubernetes cluster here. So for the environment, let's name it tests. Let's name it test for now. Okay, so that should be all for now. Okay, so let's try to run this. So the first thing we're going to do is we're going to initialize. We're going to initialize. So what initializing does is it tries to look for the plugin we are using here. So we're using the Azure RM plugin here. So it goes to download that plugin Using that plugin is able to communicate with the resource or the cloud provider it's trying to reach. So we're going to initialize here. So if you see it's trying to initialize the provider plugin, and you can see it's installing HashiCorp. So just give it a while. Okay, the initialization is complete. Terraform has successfully initialized. The next one we've run is Terraform plan. Terraform plan allows us to check what we want to execute to be sure it's what we want and it's how we want it to be. And if there are issues, it will also let us know that there are issues we need to fix. If not, we'll go on to create it. So you have here plan to add, 0 to change, and 0 to destroy. So here we go. It's telling us that it would be creating a resource group with the name HashiCorp. It would also be setting up all of this for us. All this information are for the Kubernetes cluster. So it will be creating this Kubernetes cluster, and it would also be creating this resource group. So let's run Terraform apply. What Terraform apply does is it tries to apply all this for us. It tries to execute this for us. So 3 commands, like I said, Terraform init, Terraform plan, and then Terraform apply. There are a lot of other commands that you will need to get acquainted to. But in the meantime, these 3 will get you up and running. So it will ask us if we want to accept this. We choose yes. It will take a while, and then we'll have every resource we want created for us. So right now it's trying to create it for us. When it's done, we're going to check the Azure portal to confirm that we have the resources created for us. So right here, I'll go to So whilst creating this, I'll go to the Azure portal. I'll go to the resource groups. And if we can see now, we already have a resource group created for us. So check here, the name is HashiCorp, and over here, the name is HashiCorp. And like we said earlier, we are using the subscription ID for the Azure subscription 1, which is what we have here. And then the location is West Europe, location West Europe. So it's doing exactly what we want it to do. We would want to open this resource group to see the resources we have under it. You can see it's already creating. You can see it's already creating the Kubernetes service. So it would run to create this for us. So it will take a while for this to be completed. For now, we can open it and see what we have. So yes, it's creating HashiTalks. This is the name of the Kubernetes cluster. This is HashiTalks. And then it's providing us with everything that we need. This is in nodes. Like we said, we're using 1 node count. So the node pool is 1. The VM size, which is this standard, you can see it's there as well. So we have everything we want here. We talked about environment tests. So we have that here. Now the beauty of this is we can tell just from these templates how our infrastructure is. We can tell the name, we can tell everything, and The good thing about this is we can add this to a version control like Git. So we can commit this to a repository in GitHub or Bitbucket. And then for each change that has to be made, you push to Bitbucket, you push to a branch, say a develop branch, you merge to your master, and then from your master or your main branch, you will now apply. So say you work in a team of from 5 persons. When a change needs to be made, you modify the Terraform templates, and then you push, someone reviews the code, and when they're sure that things are fine, they will commit to the master, and then you can apply it. So if you find here, you would realize that two resources were created, zero changed, and zero destroyed. That's the beauty of Terraform. Now, we can also destroy everything that's been built without even coming over here to delete this or whatsoever. All we need to do is we come here and then we'll do Terraform destroy. But before we do that, let's try to run Terraform plan again. What Terraform plan does is Terraform plan checks the states. It compares those infrastructure sheets or templates with what we have currently on our infrastructure. If there's a difference between these and what we have in infrastructure, it tries to make a change. If not, it tells you that everything's in place. So let's run Terraform plan. Now, this is the beauty of infrastructure as code. You can see that it tells me that there is nothing to be changed. And if I try to modify this to 2, and then I run Terraform plan again, it will tell me that it needs to make a change. So let's see what we'll get. To check again, you try to compare the template we have here and our infrastructure, and it will tell you that we have one to change. You can see we have one to change. So basically what it's changing, it's trying to change the node count from 1 to 2. That's exactly what it's trying to do. Okay, so we'll turn this to 1 again because we don't want to do that right now. Then we'll run Terraform plan again to compare the states of the infrastructure with the template we have here. So let's run it again and see. You can see no changes, infrastructure is up to date. And if we need to destroy everything we've created, we can just do Terraform destroy. And everything goes off. It destroys the resource group, it destroys the Kubernetes cluster. And we're back to a clean slate again. So all this which we've just done. So you choose yes, so it's going to destroy. You can say 2 to destroy, 0 to add, 0 to change. So all this we're able to do all of this on using Terraform. So we didn't have to come to home and then we having to type Kubernetes and we having to go to the Kubernetes service and we having to add the Kubernetes cluster and all of that. We didn't have to do any of that. All we simply did was pick all of this. Instead of having to type all of this, why don't we describe all of this here and then just run it, which is what we achieved. So that's pretty it with Terraform. Then there are all concerns about, there are other things you would need to also understand. Terraform uses modules. We didn't go into that. variables, reusable components. So instead of putting all these values here, we could move them to a variable file, and then we put this into a module, and we're able to reference this module in another Terraform file. So we'll have different components. So we have a component for the Kubernetes cluster, we'll have a component for say VMs if you're creating VMs and all of that. So that's a run through of how you can create a Kubernetes cluster on Azure using Terraform. Thank you so well. Thank you all for having me.